Hello everyone, and welcome to this webinar about seagrass restoration in the Canary Islands. So this webinar is part of a project that is called Los Jardineros del Mar, the Gardeners of the Sea, that is financed by Fundación La Caja de Canarias and by CaixaBank. So, hold on. First, what is seagrass? So a little reminder about what is seagrass. Seagrass is not an algae. Seagrass is what we call a marine angiosperm. So it's a flowering plant that evolved back from land into the sea about 100 million years ago, which is relatively recent. So both algae and seagrass are autotrophic organisms. So both of them are doing photosynthesis to produce organic matter. But as marine angiosperms, seagrass have differentiated tissues, while algae do not have that. So on the upper part of their bodies, seagrass have leaves, and in the underground part of their bodies, they have roots and rhizomes, while algae only have what we call a blade, which is an equivalent to the leaf, and they have holdfast, which is a root-like structure that algae are using to attach to the substrate. So this anatomical difference makes that seagrass are able to grow on sandy bottoms by creating an underground. They create an underground network of roots and rhizome, while algae needs most of the time a hard substrate like rocky bottoms to grow. And right now it might sound like detail, but you will see later that it's actually an important difference. So the Canary Islands have 4 different seagrass species, but Cymodocea nodosa, or the zebra, is the most abundant one and is also the basis of the most important ecosystem on sandy bottoms of the whole archipelago. So you will find it mainly in the southern and eastern coast of the islands, where they are sheltered from the dominant winds, the dominant swells of the north and northwest. They are found at a maximum depth of 25 meters because they need light to grow, which makes them more present on the eastern islands that have a bigger continental shelf and also have more sediments than the western islands. So Cymodocea nodosa can also be found in the Mediterranean Sea, and it can also be found in the Northeast Atlantic, so on the Africa coast, in Madeira, in Portugal. But it's important to note that the seagrass population of the Canary Islands is different from those populations because of something called the founder effect. So the founder effect is due to the fact that the colonization of the Canary Islands by Cymodocea nodosa probably started with a very limited amount of individuals. And this small amount of individuals now is parent of all the seagrass plants that we have on the archipelago. So a consequence of this founder effect is that there is a lower genetic diversity in the populations of Cymodocea nodosa that we have in the Canary Islands. So why is seagrass important? Why does it matter for humans? So most people don't even know that seagrass exists, or they are not aware that they are present underwater very close to them. So why is it important for human beings? So they are important because they provide us what we call ecosystem services. And here I have a little overview of those. So the first one is the stabilization of the sediment. So this underground network of roots and rhizomes that they develop is stabilizing the sediment, stabilizing the sandy bottom, and is protecting the coast, the beach, against erosion. It's also slowing down the water movement. The leaves of the seagrass are slowing down the water movement, and this is accelerating the sedimentation rates of the particles in the water column and increasing the visibility and the cleanliness of the water. So for scuba divers, seagrass is also very positive. Then the second point is that Cymodocea nodosa is what we call an ecosystem engineer. So this species, when it establishes on a sand patch, so a sand patch is a two-dimensional habitat, and Cymodocea comes and starts growing on it, it's adding a third dimension to this habitat. And this third dimension is creating a lot of food and shelter opportunities for species, and so a lot of organisms will come and establish themselves as well in this area. So the presence of seagrass is augmenting the biodiversity a lot. Cymodocea nodosa is also what we call a nursery ground. So many species use seagrass beds as a nursery, so the juveniles use that area to hide and feed, and including many commercially important fish species are using the seagrass. And so I have a little number to illustrate that I have it here. It was estimated recently by a scientific article that the meadows of Cymodocea nodosa in the Canary Islands support a potential fish population valued at more than 3 million euros per year. So it's quite significant. It has a quite significant importance for the fishing industry in the Canary Islands. Then the third ecosystem service, the third category, is that seagrass is a plant, so it's doing photosynthesis. Photosynthesis will produce oxygen, which is the basic for many organisms, and we need oxygen to live. And it will also capture carbon dioxide present in the water column. So the capture of carbon dioxide through photosynthesis plus the acceleration of the sedimentation rate of the particles make that Cymodocea nodosa and all seagrass species in general are what we call a carbon sink, because they have this ability to store the carbon into the organic matter for a very long time. And finally, the last ecosystem service that I think we should not forget is the cultural value of seagrass. So seagrass is providing well-being to the people visiting it when they go snorkeling, they go diving, and it's also supporting the tourism industry as a very popular diving destination. So now, what is happening with the seagrass worldwide? So seagrass beds are disappearing in the whole world, and in the Canary Islands, it was estimated that about 50% of the seagrass beds have been lost in the last 2 decades. So it's quite a big, quite a big loss, and this can be explained by the augmentation of human pressures on this ecosystem. So first, the first kind of human pressure that seagrass are experiencing in Tenerife is on the top right picture, is physical damage. So it's the most obvious one. Physical damage can be caused on this picture is by an abandoned fishing trap, but it can also be caused by destructive fishing techniques, and it can be caused by anchors. And we have to keep in mind that, for example, in the case of an anchor, dropping an anchor into a seagrass bed and pulling it out again is a damage that is happening in only a few minutes, but the actual recovery of the seagrass bed to this damage can take months or even years. So it has quite a strong impact on the seagrass beds. And that kind of damage is often caused, it's not really intentional. It's caused because the users, boat users, fishermen, are not always aware of the presence of this ecosystem, and they are not aware of how fragile it is. So the second kind of human pressure on seagrass bed is pollution. So on this picture, you can see a sewage pipe that is in the middle of a seagrass bed in Abades, and you can see that there is basically nothing going around the sewage pipe anymore. There is a kind of circle around the pipe where the seagrass cannot grow. And this is because Cymodocea nodosa is very sensitive to water quality and can be heavily affected by the presence of discharge. It can be discharge of sewage water, like in this case, but it can also be discharge of desalination plants. They're also very sensitive to a higher salinity, and in the Canary Islands, we have quite a lot of desalination plants. Then a third threat that they are experiencing is coastal development. So here I have a very good example. The picture is showing the harbor of Granadilla, which was built in the south of Tenerife, in the middle of one of the biggest seagrass meadows that the island had. So coastal development and the fact of making the coast more and more artificial is causing direct destruction of the seagrass bed because they build infrastructures on them, but it's also causing indirect effects on the seagrass meadows around it. Because, for example, in the case of the harbor, the wave breaker will change the hydrodynamics of that area. It can change the currents, it can change the sedimentation rate, and this can cause, for example, that the seagrass beds gets covered by sediments and just does not have access to light anymore and dies. Or it can also happen that simply the visibility of the water changes and the access to light gets lowered because of those constructions. And so all those pressures together, there is one more pressure here, which is the invasion of the meadow by opportunistic algae. So on this picture is Colerpa prolifera. That kind of cohabitation is happening in nature, having seagrass mixed with Colerpa prolifera. But scientists have observed that more and more Colerpa tends to invade and take over Cymodocea nodosa in the seagrass meadows, and they think that it can be explained because of the lowering of the water quality and of the access to light. And this causes that the Cymodocea is losing the competition against those green algae. So all those threats together, all those pressures together, cause an area loss every year in the seagrass beds of the Canary Islands. And a recent paper has estimated that if the degradation rate doesn't change, if it keeps the same as it is now, the species Cymodocea nodosa could vanish from the islands in 2036. So it's in a very short time. It's only in 13 years, and something must be done to avoid that. So what do we do? What is the authorities doing to protect the seagrass? So seagrass, Cymodocea nodosa, is protected at 3 different levels. First, the regional level. So at the level of the archipelago, seagrass is categorized as a species of interest for the Canary Island ecosystems. The problem of this cataloging, this category, is that this requires to protect the species only within the already protected areas. So all the seagrass meadows located outside of protected areas do not require any protection because of this status. Then the second level of protection is at the national level, where Cymodocea nodosa was categorized as a vulnerable species in the Spanish catalog of endangered species. And this is specifically for the population that is in the Canary Islands. And finally, at the European level, the seagrass beds are included in the directive habitats, and so are supposed to be protected by all European states because of this directive. Next to having a protection on the species itself, on the plants, seagrass beds are also home to many protected species or endangered species. For example, the most popular one, the most famous one is the green turtle on the bottom left, which is endangered. Seagrass beds are also home to angel sharks that are critically endangered and are also an important area for their reproduction. And finally, you can also find butterfly rays or mantellinas in seagrass beds. So on this map, you can see the different the different areas of special conservation of Tenerife. So the green squares you can see above water here are describing some areas that have been designated after the directive habitats with the objective of protecting some marine habitats of Tenerife. And so all those protected areas here are part of the Natura 2000 networks. And so Oceana has been working on seagrass for many years, and they started with the project InnoMapas in 2020. So they have been studying during this project the seagrass meadows located in the special conservation areas Cebadales del Sur de Tenerife. And the objective of this project was to map the seagrass meadow and to identify the human pressures on it. Then the project continued with InnoMapas DOS in InnoMapas 2 in 2021 that had the same objectives, but this time in the two protected areas located in the north of the islands. So the SEC of Cebadales de San Andres and the SEC of Cebadales de Antequera. And finally, the last project, El Suelo de Cristal, ended only a few months ago. And the objective of this one was to study the Cebadal, the seagrass bed present in the SEC Franja Marina de Tenorasca. Next to those projects of mapping and identifying the human pressures on Cebadal, Oceana also participated to some parallel projects, for example, to a study on microplastic impact on seagrass beds. And so this comes to the objective of today's webinar, which is seagrass restoration. So after studying the seagrass of Tenerife, after mapping it, knowing where it is, knowing the kind of threats it is experiencing, the next logical step for Oceana is to start active restoration of this ecosystem. But to know how to restore this ecosystem, we need to know how they propagate. And if you have listened carefully at the beginning of the presentation, you probably remember that Cymodocea nodosa is a flowering plant. So it's able to reproduce sexually by producing flowers. But it's also able to reproduce asexually or clonal reproduction. And this is actually the main reproduction mode of this species. So first, the asexual reproduction. This is happening with the rhizome, the underground rhizome of the plant. This rhizome can grow vertically to fight sedimentation, and it can also grow horizontally to extend the seagrass bed. So this rhizome will go little by little horizontally and progress under the sandy surface. And every X centimeters, a new shoot will go out and form a new seagrass shoot, a new plant. And an interesting fact about this way of reproduction is that the shoot itself of seagrass is thought to have an average average life of 1 year. So they usually die pretty quickly because they get eaten by predators. They can also get uprooted if there is a storm or something. But the clone itself, so the rhizome and the genetical material, is thought to live about 10 years. So it's quite an interesting fact. So all those plants are genetically identical. Then there is the second way of reproduction of the seagrass, which is sexual reproduction. So first, it's important to note that not all seagrass patches and not all plants within a seagrass patches will be doing sexual reproduction. It's only a percentage of them. And it's also very important to note that this way of reproduction has a very low survival rate. So the results are not very high for the effort that they put in it. And this is working with a yearly cycle, a bit like flowering plants that we have on land. So I will start here with the flower. So the patches that are doing sexual reproduction will start producing flowers between March until about June. Seagrass have male and female flowers. So on this picture, it's a male flower because it's more visible, but female flowers look different and they are very small and green. And those flowers will get fertilized with pollination through the water, and this will generate fruits. So every plant on average has 2 fruits, and those fruits will stay attached to the plant from the summer until, for the latest one, until December. They will stay attached at the basis of the plant. At some point, they will detach from the plant and form the seeds, and those seeds will stay buried into the sediment and will enter a dormant stage of 7 to 9 months. And then only a very small percentage of these seeds will naturally germinate and form a seedling, so a small plant that will grow again. And after 1 year, more or less, they can make new flowers and continue reproduction. So now that we know the 2 techniques that seagrass is using to propagate, well, basically, the restoration of seagrass also has 2 techniques based on those 2 modes of propagation. So the first technique that has been used in the past is restoration through direct transplantation. So this technique has been used, for example, in the case of the harbor of Granadilla that I showed you earlier. Before building the harbor, they have tried to displace a part of the seagrass bed to the north of the island to hopefully preserve the species and save it from destruction. So the technique is very basic. They are manually extracting the seagrass plants from the donor meadow, and they really extract the whole plant, so they have to take as much rhizome and roots as they can, and they will transport it to a new area and plant it there in a certain pattern with some distance between every plant, with the hope that the plants will start growing and will connect together and form a new seagrass bed. So this is the first technique of restoration. Then the second technique of restoration is using sexual reproduction of seagrass. So we are using the seedlings. For this technique, the first step is to search for a donor meadow because, as I told you earlier, not all meadows are doing sexual reproduction. So first we need to find a meadow that is producing seeds. And in the case of Tenerife, for example, in Abades, we didn't see any flowers yet, but I have read that the meadow in El Medano, for example, is producing a lot of seeds and flowers. Once we found a donor meadow, we will go diving there and collect the seeds. And then there is the option of placing those seeds in kind of protective sheets and putting those protective sheets back into the environment and let them germinate underwater like that. But as I said earlier, the natural germination rate of seagrass is very low. So there is a second version of this method that is improved. There is 2 more steps. So once the seeds have been collected this time, they will do an in vitro germination. So they will generate the germination of the seeds. They will induce it by putting them, for example, in a hyposaline environment, so a very low salinity environment. This will augment the germination rate, and then with the seedlings, they will let them in an aquarium for about 30 days to let them grow and acclimate to the environment. And finally, the last step is the same, transplanting the seedlings into the natural environment and hoping that they continue growing there. So seagrass restoration, there has been many projects in the Mediterranean Sea, but it's difficult to import the protocols and the techniques that they have been using in the Mediterranean Sea to the Canary Islands because the conditions are different and the plants also are different. So in the Canary Islands, there has been a few pilot projects that have been more or less successful and that have been using both techniques. And when you review those pilot projects, you can identify two main factors that are playing in the success of the project or not. So the main factor number one, would be the wave energy. So seagrass, especially at the first stage of development, are very, very sensitive to the wave energy, as they didn't grow yet the network of roots and rhizomes, so they are not very well attached to the bottom. And so it happened, for example, in the project of Granadilla, they have planted all the seedlings, they have planted all the plants from the south to the north. And after a few days, a storm happened and uprooted most of them. So all the effort was lost. And in the end, just one storm was enough to destroy the new meadow. And so one of the ways to reduce this risk is to install some protective infrastructures around the meadow. So you can see here that they have put a kind of mesh around the meadow to reduce the wave energy. Here, the technique with the seedlings, they have put some metal arch to hold the sheet inside the sediments, into the sediments. And here in this project that was more recent, they also use kind of plates to protect the plants against wave energy and to let the plants really settle down. And so those infrastructures are not meant to stay in the environment the whole time. At some points, they are meant to be taken off to not leave any trash behind and let the plants continue to propagate by themselves. The second bigger risk is the water quality. So if there used to be a meadow somewhere and the meadow is not there anymore, most of the time there is a reason for that can be the water quality. So it's very important to choose carefully the transplanting area where you are going to put your new plants and to really evaluate the water quality to see if it fits or not for a new seagrass meadow. Otherwise, again, the effort can be destroyed because the plants will just not appreciate the new environment and die. So a little summary of the two restoration techniques that I have described before. So the direct transplantation technique is cost effective because you don't need a lot of equipment, and it's very fast because you can do it in less than a day. But the disadvantage, the downside of this technique is that there is no genetic diversity induced. You are only displacing clones from one spot to another spot. And the biggest disadvantage is that it's a destructive method. So to be able to create a new meadow somewhere else, you need to extract the plants from an already existing meadow. And so you need to induce physical damage to that meadow. And the second method for seedlings, seed propagation, of course, is much more costly and work intensive because it's much longer in time and you have more steps to arrive to the final results. But an advantage of this technique is that it is generating genetic diversity because it's based on sexual reproduction. And also it has a low impact on the environment because the only impact is the seed collection at the beginning. And if you don't do it in an intensive way on one area, in the end, the impact will not be very strong on the meadow, on the donor meadow. So this is it for the presentation about seagrass restoration. Does anyone have questions?